Okay.
Hello everyone, my name is Bhavik Vyas. I work for Amazon Web Services and I manage our global partner ecosystem for media and entertainment. And today I'm going to talk about considerations for broadcast player in the cloud, potentially the unicorn of our media and entertainment exploration for workloads. I'm going to walk through a number of different aspects of the cloud platform. So why customers are looking at, or digital media customers are looking at the cloud, what benefits it brings to them, what flexibility. And then we're going to talk about how those companies leverage the cloud for their next generation business, what key pieces of the platform are relevant then for Playout specifically. So that would be key services, key architecture designs, how you build for failure in the cloud specifically, especially for broadcast where it becomes critical to have continuity of Playout. And then I'll get into some of the software applications. So if we look at the application layer of broadcasting, just some options about how you can actually begin to solve the broadcast playout, scheduling, and actually getting the signal out to your consumers. So we're extremely fortunate at Amazon to have some wonderful digital media companies using our platform, companies like Netflix and Lionsgate and Uyala providing services, PBS, Condé Nast, all transitioning their digital business, either building it from scratch or moving from legacy businesses to fully digital on the cloud platform. And it might be useful to sort of go through some of the key things that they see when they're looking for a cloud platform and what they're hoping it's going to provide for them and what they actually need in order to transition their business. Of the companies I mentioned, we have over 1 million active customers on the AWS platform from over 190 different countries, and we believe we can run virtually any workload, and so broadcast playout actually becomes a very interesting new workload that we're looking to solve for. The first thing our customers want and that you should look for is security. So securing your applications and your business and your customers' data and your own data is a paramount requirement for what you do on premise or what you do in the cloud. And so the ability to secure broadcast, especially because it's so revenue critical, and 24/7 by 365 in some cases, that security and operational security and governance become essential components. The ability to build like you would on-premise, which is essentially creating a private construct for yourself in the cloud. The ability to isolate resources, to select your own IP addresses, to build virtual private clouds, which we'll get into later, become essential to the design and choice process. The ability to be compliant. Many of our customers work in regulated industries, so healthcare, financial services, government agencies. So the ability to meet compliance, and even in media and entertainment when we get to the PCI level or complying with MPAA, there are certain regulations just from an industry best practices perspective that become key to operating and building and migrating workloads to AWS. And then finally, the ability to build hybrid workloads. And so we know, and there will always be the requirement to come back onto premise to do something or to originate content from on-prem. And so the ability to correctly couple and correctly build hybrid workflows and hybrid architectures becomes essential to this thought process and this design process as one goes forward. In terms of benefits, not to spend too long on these, but the cloud offers interesting differences to the way you might do something on-prem. The primary one being that you can transition from capital expense to a variable expense. Only pay for what you need when you need it for as long as you need to. You can also benefit from the economies of scale. So with Amazon, again, being very fortunate to have over 1 million active subscribers, we can buy a lot of equipment, both hardware, lease data centers, buy bandwidth, storage, and we can hopefully then buy that at a price point that is different to if you're buying it on a one-on-one basis. And then our ambition is to always offer the lowest cost we can to our customers. So dropping prices continually is a thing you can see, and no one's complained about from our perspective, but it's difficult to achieve that when you're just buying things on a one-on-one basis. The important need to stop guessing for capacity. We all work in an industry where the success of content or the fast-moving nature of the business we're in and the way news moves or sports moves or the way social media will drive interest becomes very key. The ability to meet that demand and meet that efficient marketplace requires you to have capacity. And if you're worried about not having enough, hopefully the cloud is one option where you can say, well, this company is built to meet that capacity need, so it's one less thing that I have to worry about when I'm designing for content delivery. The other thing this allows you to, actually, all of these things together, is to infuse an ability to be speedy and agile with your business. And as we transition to digital, the ability to be speedy, to move fast, to meet your customers' needs becomes an essential component to delivering content in the right time frame based on customer need and release windows. The ability to go global is another one, so having a global common platform for you to deploy applications in based on the need and demands of your customers and your end users becomes another consideration. And then finally, the ability to reuse the capital and the money that you generate, right? Instead of spending the money on running and maintaining data centers, perhaps that money can be used for other alternatives, either driving the business, innovating on new products, and things like that. So these are the core tenets. When we marry them with media, we think there's an interesting correlation and amplification. So if you can trade CapEx for variable expense, is there the opportunity to reuse that money for return on investment that might be placed in the actual products and services that you're developing and pushing out? So could you create better content? Could you invest in your customers' experience and allow them to actually have a better return on investment in the subscription they might be paying you or the movie they might be watching? If you can benefit from the economies of scale, you release yourselves from being reliant upon tracking and investing in new technologies to support new requirements when it comes to media. So if we're responsible for building the platform and running it, investing in technologies, procuring that equipment, installing it, and running it, hopefully that allows you as a media customer to move faster about meeting the needs and trends, both technologically and from a business perspective, as you look forward. The need to stop guessing capacity, I'd mentioned that earlier, but where this becomes really key is in the unpredictable and bursty nature of our business. Again, if you are unable to service the demand on your content, that means you're missing out on either impressions or delivering the right expectations to your customers, or you're missing out on revenue where that capacity isn't available. And so the ability to handle and not have to be concerned specifically about the capacity that you might have to worry about becomes an essential blocker or removing that roadblock becomes an essential component, again, to that scale and that future look. The same with speed and agility. So what does that mean? Hopefully that will mean that as you move to the cloud, again, by focusing on less of these undifferentiated components, you can decrease your time to market, you can hopefully offer more options for your customers, and you can always meet that demand. Again, we're not worrying about the capacity problem. But this time to market window, I think we're seeing change in our industry. After theatrically, sometimes Blu-rays will come out, sometimes digital media will come out, and you might want to actually mix the availability of VOD or content delivered digitally even before the physical or during actually theatrical release. So the ability to dynamically change the way in which you release content is really a function of your capability of actually encoding it, storing it, delivering it, prepping it for CDN, all of the complexity around content delivery. And the same with the global nature of our business. We are trying to sell in a global marketplace now, where that demand can be unpredictable. We used to have a model where different release windows might occur, but in a world where social media drives most of our interactions on a personal level, the ability to connect with someone around the same media from a global perspective becomes an important way in which you can engage with your customers. So having the ability to deliver content or to process content or even to acquire content on a global basis on a common platform with common software that you're running and with common operational back ends allows you again to achieve the speed, achieve the agility, and really meet the customer demand. And then finally, the not spending money on building and maintaining data centers is really around the resource focus. Are you better off spending your time managing, building, and operating a data center? Or are those resources better placed elsewhere with respect to your end customer goals, the services you're offering, the content that you're delivering, and the engagement that you're trying to drive from a business perspective? Obviously, for us, we're in the business of running data centers, but we generally think that a lot of customers are not, or they do it by necessity, and maybe there's a future opportunity to do less of that. From a global perspective, we operate a global platform. Many of our services are available in all regions. We operate 12 global regions. We have availability zones, which allows you to build for redundancy. We have 54 edge locations for content delivery. That's our CloudFront CDN. And then we've announced 4 new regions in the last year: Ohio, Canada, London, and India, which will all be online in the next 12 months. So this again allows you to see how that global availability becomes very key. You can replicate and instantly turn on new regions. And so when we tie this back to broadcasting, it becomes interesting. If we think about OTT and linear playout, the ability to experiment becomes possible when you don't have to build, lease, and invest in the infrastructure needed to support the application. So we have a big array of products on our platform, many different ones, and I'm not going to go through each one individually. What I thought I'd do is just highlight it. From the infrastructure perspective, we've got the global availability in our regions. We have core services that are fundamental to the platform: compute, storage. We have a CDN. We run databases, both managed and you can manage yourself. And then we have all the networking components. So that's your base, your fundamental building blocks for a data center. We then, though, begin to add much more important services to help govern and control your business. So from a security perspective, the ability to do identity management, to enforce access control, to manage encryption keys. From the hybrid architecture perspective, the ability to do private connections into the cloud, the ability to do federated identity access, the ability to deploy Active Directory. From the enterprise perspective, the ability to virtualize your desktop, to share and collaborate with your content. From an enterprise personnel perspective, the ability to deliver corporate email and backup services. And then a bunch of different tools, and this is where we'll focus on for broadcasting, a bunch of different tools that let you build and automate your infrastructure to support a 24/7 broadcast playout. So this is things like synchronization, or big data analytics, or simple workflow, or resiliency and metrics gathering. We then have a whole piece that focuses on IoT, not the focus of broadcast playout specifically, but becoming a very ubiquitous piece of the way in which we interact from a social and consumer perspective. On top of which you can buy a ton of different products and services from a marketplace, and then all supported with solution architects and phone and email support from a governance and operations perspective. So these are the key building blocks of a portfolio that can do many things. And again, a strength of the platform. What I'm going to do next, though, then, is now focus on which pieces of those might you want to begin to consider as you begin to design a platform for playout specifically. And so why the cloud for playout? So we see a number of drivers that our customers are looking at or facing as we look forward. One is the transition from SDI to IP is happening, or has happened for a lot of people. That is now amplified in terms of complexity by the move to UHD or 4K, HDR, which we've seen some presentations on. The shift from linear to OTT, so that you can, one, expand your window of viewership and count those, but then all of the different myriads in the way in which you might want to offer your content and control the revenue flow. So subscription VOD, advertising-based VOD, transactional VOD, the ability to do dynamic ad insertion, the ability to integrate with social media, and obviously the ability to always have your content available anywhere on any device. And so mobile becomes a very key piece to this, either second screen or natively as a playout. The requirements to provide these technologies then fall back on the compute and storage platforms that you decide to have. And so when you buy servers and you spec them out and you install them, you hope that they're going to last as the technology that we deliver content with and the way we want viewers to experience the content match the actual hardware that you might have in place. And so with the cloud, again, back to that economies of scale, we hope that our job is to invest in the right technologies at the right pace and at the right scale, such that you as the content owner and the application owner can quickly mix and match the right application to the right infrastructure. And because there's no commitment, you can quickly switch in and out which pieces are essential, which pieces are old, which pieces you might need. And as we evolve our platform and we work with companies like Intel to get the latest chipsets, you can take advantage of them by just simply moving the software and not having to replace or buy or procure that hardware yourself. The cloud also allows you to own the digital lifecycle. So from content capture, potentially, to storage to the production environment, potentially editing, all the way to distribution. We're seeing our customers begin to change the way in which they want to change that entire workflow. And if you can leverage the cloud for that acquisition piece, be it both live or as a file, then you can begin to bolt on lots of different processes to help own that true end-to-end. And then the other trend we're seeing is the ability for our media companies to really build their own expertise around a media factory. So if you think about content, it comes in as a raw frame, typically, if it's digital, and it will leave, and we'll consume it on any device that we intend, from both the theater down to our mobile device. But everything in between that is where all of our complexity lies. There's a digital supply chain, there's the need to do closed captioning, there's the need to deliver certain pieces of that content in different formats for different regions, there's the need to add different language packaging, DRM, subscription management, you go back into the VOD, and what that really is now is a content factory. And so we're seeing our customers look to build expertise, operational expertise, about building content factories from a DevOps perspective, from a SysOps perspective, from a business perspective, realigning their engineering teams to really understand not just shift and lift to the cloud, but really build a next generation practice around delivering media as a core piece of the business. From a business continuity perspective, there's many reasons why the cloud might be useful. Generally, there's a hybrid approach to Playout. It's going to have an active-active or an active-passive component. And so the ability to augment one of these pieces with the cloud becomes a very interesting opportunity. There is the ability also to do cloud-only deployments. So if you're just originating pre-recorded content and you want to create a channel that looks like a live linear channel, but it's all pre-recorded, there is the possibility to do that totally from the cloud. And we have this line that I like, which is friends don't let friends build data centers. So if as you go to a transition point, if you have a legacy data center or you have lease expiration, or you really need to replace the large majority of your legacy broadcast equipment for new, does it make sense at that point to build and invest in a data center, or does it make sense to look at a cloud-based deployment? And there's no answer, there's no right or wrong answer there, but it's a question that is beginning to be asked by a lot of customers, because that's a very big outlay that one would have. And that's where we get into the commercial and financial. So why invest in hardware? Why invest in real estate? Why invest in the personnel to manage both if you don't have to? And that's a fair decision to ask, even as potentially as a shareholder of a company that's public and they're looking to spend large amounts of money or shift that money into content and subscriber retention and growth. Audience engagement is another key one. There is less potentially if you're not investing the capex amount of your financial component and fixing it into assets, you have the ability to be a bit more flexible in the way you might want to explore new business models. So pay-as-you-go allows you to just use what you need when you need it, which is PAYG. The OpEx model, so again, variable expense, being global and having no commitment, those are great things for experimenting with content. There's no risk to setting up a channel. There's no risk to experimenting in a new region. There's no risk to it because if you're not paying for that outlay and you have the software that will develop, you have the content and it's already prepped, then the ability to engage an audience in very different ways is possible in a faster way from a cloud-based perspective. And then that falls back on what are we trying to do with our customers, right? We need to be more agile to meet the needs of our customers. We have to win what they're watching, and they can only watch one thing at once. So it's really getting above the noise and delivering the right content and the right experience to them on a continual basis. The ability to meet the need of short-term programming windows. So that could be live events, it could be sports, it could be special events. And then the ability to match demand. So it comes back to really meeting the need of the customer in all of these different flavors. If you are not meeting the needs of the customer to watch your content, then that's not a great experience, and that's what we hopefully be able to solve with sort of innovation around Playout, specifically on this topic. So what are the services for broadcast Playout? So we've got a number of components. I grew up in the UK, and in the UK they used to show this picture when the channel wasn't live anymore. It could be a fuzzy screen, right? And so we don't want this. If you're going to do linear Playout in the cloud, you cannot have a break in transmission. And that's why these components become really important. So you have to begin to consider what your security model is going to be, how you're going to do your networking, how you're going to get content in and how you're going to get content out. You have to look at what type of instances are going to drive the right type of content output. Do you need to use GPUs? Do you need to use CPUs? Do you need certain types of chipsets or certain amounts of RAM? How are you going to stage your content and how are you going to store your content? How are you going to bring it in? What's the supply chain piece going to look like? How do you move content from different types of storage mediums to a Playout server? What's that architecture and storage like? How do you then manage the movement of that data? How do you automate it? How do you build your schedule? How do you ensure that 48 hours of content is available for Playout in 2 different locations at the same time for redundancy? How do you fail over in the cloud? So I'm going to go through later some options for both a hybrid deployment and a cloud-based. But even in the cloud world, our fundamental principle in helping our customers design is design for failure. And so there are many different ways in which this can be achieved. And then what are the HA and DR scenarios for that signal output? So specifically, the signal as it comes out is the key piece, right? That's what avoids this blank screen. And so understanding those scenarios and choosing the right one becomes an important consideration. How you do automation and deployment. And so this goes back to a little bit about the global nature and the quick up and quick down that we could do in the cloud. If you can automate the delivery of your software, you can automate your configuration, you can automate the way in which your content arrives in the cloud, then you can begin to build a very scalable, adaptable, but then dynamic broadcast system. And then finally, how do you do operation and monitoring all of this? Because it's a continuous 24/7/365, and then what are the tools and instrumentation that you might need to insert into this operation? A lot of stuff. So if we start with security, so we have many different options to secure the infrastructure from which you can play from. VPCs, which is virtual private cloud, which I'll get into. Obviously, transport layer security. So this is encryption with data in transit. We've got the network ability. We've got denial of service capability to really protect the infrastructure from external attacks. We've got the ability to inspect all of your aspects around configuration, both security, the way you're deploying and managing the infrastructure. The ability to manage encryption keys, which becomes essential. Encrypting data at rest, encrypting your content, encrypting any aspect of your business operations so that no one can easily get access to it, or only those that are allowed can get access to it. And this applies both to people and processes and applications. So you can grant access to a person. You might similarly want to do that from an application perspective also. The ability to do identity and access management, multi-factor authentication, the ability to really protect the infrastructure just like you would if you were managing it as a data center on-premise. The ability to log every transaction becomes super important. So this allows you to do log analysis, but it allows you to control every aspect, every API that's called, every one that touches a server, every one that does a configuration. It allows you to look back in time as to what was done. So if you ever need to audit or you need to show proof of something, or you just need to look at what's going on, then you have those abilities. And then finally, through our partner network, we have amazing innovation from partners that augment all of these different things. They will provide instrumentation. They will continuously check the health and the security configurations of the AWS environment. And so these in conjunction, using all of them together, give you both an enterprise security platform and then a media-grade way of operating it, such that you can then, as I say, focus on the business, which is outputting the channel. So virtual private cloud is the ability for you to isolate logically your infrastructure within AWS. And it becomes really important because it lets you configure your own private IP addresses, allows you to create your own subnets, and it allows you to ensure that the routing of traffic between VPCs is fully controlled by you. It's nothing to do with AWS. These are all constructs just like you would build in your data center to build that construction. And what it also allows you to do is it allows you to extend your on-premise footprint with the AWS cloud and even use common IP address ranges such that whatever is in the VPC could theoretically be only accessible through a network connection that is directly connected to your corporate data center. And that ensures complete control of what's in AWS, your data, and then how your traffic is specifically flowing. And the way we do that direct connection is through something called Direct Connect, which becomes a really important component for Playout, because This is a dedicated connection, point-to-point, between your data center and the AWS cloud, and specifically an AWS region. It offers consistent network performance. You can buy it in various grades of bandwidth, 50 to 500 megabits per second, 1 gig or 10 gig. And this 10 gig allows you to go much higher than a dedicated software or hardware-based VPN speed. And then from an IP perspective, you then deploy BGP, which lets you manage your IP address pools. And this allows you to fully connect with a guaranteed latency, a very low packet loss link, where you're routing your own IP addresses to what would be then your VPC, which is your virtual private cloud. So this allows you, both in conjunction, it allows you to build a fully remote data center that could be connected directly to your broadcast playout facility or your on-prem facilities. Next would be, then how do you choose the right storage? So the storage for the application becomes key. And as we look at the supply chain of content, as you source it, be it both live or pre-recorded, and then how you package it up for delivery becomes key. So we have three different ways of, just commonly standard, three different ways of looking at storage. There's a file-based, there's block-based, and then there's object-based. So within the platform, you can choose different components to suit the specific needs of the where you are in the workflow. So from a file-based perspective, we have elastic file storage, EFS, which is a low latency shared NFS file system and storage backend, which allows you to do shared storage services for multiple different applications that might be looking to access the same content. When we come to the block level, we have Amazon Elastic Block Storage, or EBS. This is based on SSDs. It allows you to provision multiple terabytes together and associate them with a compute instance of your choice. And this allows for extremely low latency, very high throughput I/O to that storage medium. On each Amazon server or virtual instance, EC2, you have also magnetic or SSDs that are also used in combination. So just like you would if you purchased a server, you can buy a server with a certain amount of onboard storage, which would be the instance store. You can then augment that with EBS, which expands out that directly attached storage, and then we also have the elastic file system that you can connect. From the object basis, we have Amazon S3, which allows you to access an object, a file, through HTTP or HTTPS. It's global. It's highly available. You can choose which region you store that data in, and it can be accessed, the same data can be accessed at the same time, and we're taking care of the front end in terms of load balancing that content. And then we have Amazon Glacier, which allows you to archive that object store into a much lower cost but highly durable storage volume. So this would give, if you look at a traditional workflow, it would give you a library or an offline archive. It would give you shared storage. We have block level for processing, and we have a shared file system for applications that need to read and write potentially to the same content at the same time. And then finally, we have a bunch of different partners that will augment these solutions also. So if you need to build your own shared file system, you can. You can leverage these components. If you need to have different ways of addressing and using Amazon S3, you can leverage a large partner ecosystem dedicated to storage that help augment these platforms. Then we come to choosing the server. So the server is going to be key for the playout type that we're going to do. So you can choose the server based on the application. And this presentation is meant to be very high level, but there's a ton of different components that will come together to actually do playout. There's going to be monitoring of the signal, there's going to be doing the scheduling, there's going to be managing the asset management pool. And so choosing the right server to match that application becomes essential. And we have many different classes, 5 different classes: general purpose, high performance compute, ones with more memory, ones with very high storage throughput. And then we have a GPU class of server. And this becomes really key for the playout component. So when we do playout, we often want to insert live graphics onto each frame that the viewer is seeing. So that could be a bug or a logo. It could be a scrolling ticker tape. It could be live graphics that you're inserting. It could be newsflash data, or it could be just rich media that you wish to insert into the viewer's experience. And so you can use the GPU instances to do that live rendering, or you can use those GPU instances to pre-render content that you might want to switch in and out of your schedule. And so GPU becomes essential, at least we've seen so far, to that playout piece, because it lets you do the live and the dynamic, and it lets you do different type of channel constructs. So those are our building blocks: storage, compute, networking, VPC. So now we'll look at how you build for failure. And the other way to look at this is how do you build for automation? How do you automate the system so that it can scale up, it can scale down, and it can fail over when and if that's necessary? One of the fundamental building blocks for this is something called AWS CloudFormation, and this allows you to construct basically a blueprint of how you want your infrastructure and your applications to look, how you want the server to be configured and installed, what usernames, what passwords, and then what applications are going to be installed, how they're going to be configured. And so you can then, once you've written this, and this becomes really important for failover too, you want to be able to replicate the same thing over and over again if needed. If you're adding more channels, you want to replicate exactly the same stack on the same instance types. If one of those instances fail, you want to be able to fail over, so you need the same stuff. So this helps you both scale the infrastructure up, helps you scale it down, helps you replicate it both regionally and potentially globally. And then you can also define exactly how the networking and the routing and everything, the way the whole infrastructure comes together. And so CloudFormation becomes that essential tool. We also have multi-AZ, which lets you do failover, so you can run different servers in different locations within the same region, and you can have scaling groups that are cognizant of each other and that will scale up and scale down as needed. Obviously, multi-region allows another way to build for failure. So if you're outputting a channel from the cloud, if you want true redundancy, you'd want to choose both different availability zones for playout, and then you might also want to choose a different region so that you've got two sources of that content playing out. And so this is where our multi-region approach helps with that delivery. And then finally, you can build in even things like redundant direct connect connections. So you could have two different direct connects into the same region to allow for two playout channels to occur at the same time. So multiple ways of both automating and then building for that redundancy. Then how do we automate the workflow? So we've got a number of different tools that help you build queuing and triggering mechanisms and monitoring mechanisms within the stack. So Amazon Simple Queuing Service allows you to build a messaging bus and a queue to execute commands and keep track of state. That queuing service allows you to do that. Then we have Simple Workflow that lets you keep track of state and actually initiate pieces of that infrastructure spin up or spin down, or even potentially parts of the supply chain. We have Amazon CloudWatch that will manage the health and instrumentation of the infrastructure so that you can trigger new additions if your CPU is maxed out, or if your network services are maxed out, you can add more capacity as needed. We have CloudFormation, which I mentioned, which lets you automate that build out. We have Amazon EC2. So I covered the core pieces, but what becomes very interesting here are the ability to do auto-scaling, the ability to leverage our spot market, which allows you to get access to high volumes of compute at a market price. You bid for that compute power. So using that as a way of lowering costs also becomes very interesting. Elastic Beanstalk for automating web deployment. And then Lambda for serverless compute. So if you need to run short compute tasks for a 5-minute window, instead of running a server, you can actually simply install the code on Lambda and execute your event and then close it down. Elastic Load Balancing allows you to scale up and down, and then Amazon Elastic Transcoder is a way of just doing transcoding in addition to other solutions, which we'll get into next from Elemental. So from a design pattern perspective, so these are all the pieces, very rushed way of explaining everything as it comes together. So I'm going to move to some graphics. So if we look at ways in which you might want to architect the deployment. So this is a hybrid cloud active-active configuration. So we have AWS being one signal source A, and we have signal source B being on-premise. And we can use Direct Connect to go from that live or that file-based outflow. And both signals can be synchronized. You can play the same content, have the same signal being transmitted from both locations to a distribution hub that will then choose the best signal for that distribution. Similarly, we can do it in an active-passive way. So you can use the AWS cloud potentially for that DR solution. You don't have to build it, right? You don't have to pay for it while it's not being used, but you can fail over. So if there's a signal break in the main flow from on-prem, you can quickly fall over to the AWS cloud. You would have the same content. You could be theoretically playing exactly the same signal with the downtime equivalent to that switch over time. So it's two different ways of doing it. So that would be for sort of live and pre-recorded. If it's all pre-recorded, there are ways of doing everything from the cloud. You can originate, if you're sourcing all of your content, if all of your content is available on the cloud, then you can simply play out from two different regions with a synchronized playlist with identical content. You can have it coming over Direct Connect. You could build designs where you fail over to the internet, depending on the throughput rate that you need on your transport stream, and then that can also go to the distribution center. And then similarly, we can do the same with a hybrid approach, where we can deploy the same architecture, but we can have the active, passive, but all pre-recorded content. So if we pull everything together at the application level, so actually the transition here is that's all of the infrastructure that I was describing, all of these scenarios. Nothing specifically covers the software that's going to do the magic. How do you get the content? How do you build the playlist? How do you move the software, the files to the right place? How do you render them? How do you insert the graphics? How do you then play out an MPEG transport stream to your broadcast center? So 2 different choices for that. One of them, with our acquisition of Elemental, becomes a super interesting way of doing exactly the same thing. You can have all of your content, if it's all pre-recorded, available in S3. You can use Elemental Live and Elemental StatMux and Elemental Delta to do all of the different nuances about constructing that signal for output. You can connect it to an automation and scheduling system, and you can generate that transport stream coming out of the data center to the uplink site or to the distribution point. So you can, and for live, you can ingest the mezzanine stream and do exactly the same. So that could be for ad insertion, it could be for both live and pre-recorded channel mixes. But that green line is where that content is going to come out of the cloud for distribution. That's one way with Elemental. We're very fortunate to have a very robust partner ecosystem that can do similar things. And so I'm going to focus in on one for broadcast playout specifically, and that's our partner Evertz that's doing a very similar thing. There they have asset management, scheduling, and the live rendering of that content for outputting a linear MPEG-2 transport stream from the cloud with a supply chain that will front-end it. So all of that content will arrive in AWS and be processed by this workflow. And so that green line is where that content will be packaged, rendered in real time, distributed out over Direct Connect onto on-prem, where you can add more complexity to that channel mix and then output for distribution. I'm going a little bit over, so I apologize. So in summary, we believe the cloud is ready for broadcast. We think we have a platform that meets, hopefully, most of the needs for actually designing and deploying such a system. We believe that the need to move faster is going to be key for all of us as we look forward, especially from a customer engagement perspective. The ability to handle the unexpected, to bring up new channels, to handle for failure, to build without the capital outlay, we think becomes a very interesting trend and an opportunity for customers to redefine the way they're doing it. Faster time to market becomes a key one. The ability to be global, again, multi-region, same content in different continents, packaged in different ways within the same release window. And then finally, a very powerful ecosystem of partners that will complement both the infrastructure, the application, and the security, and then the playout components to really deliver the signal. So with that, I'll say thank you. See you at NAB.